To get this started. My name is Kelly Scott. I am coordinating the Farm Robotics Challenge this year for UC Ag and Natural Resources, and we're thrilled that you joined us today. This is our second team webinar. We had one last week where we talked about the deliverable of the team project proposal, and really the first part of that is working with a farmer or an ag partner to define the problem that you're going to go out and solve. So we wanted to provide you with some really relevant programming around problems and challenges in farming. So we are just thrilled today to partner with the Farm Foundation on bringing in farmers to have that discussion. What are some of the problems and challenges that they're facing in ag? So as we go through the program, if you have a question, please just type it into the chat. So we'll be monitoring that, and we'll get those questions out to the panelists so we can have a really engaging and lively discussion. So at this point in time, I'm going to hand things over to our moderator for the day, Mr. Tim Brennan, Vice President of Programs and Strategic Impact for the Farm Foundation. Tim, it's your show. Take it away.
Beautiful. Thank you, Kelly. Thanks, everybody, for joining us. And a special thank you to our speakers today. We have with us two of my favorite farmers in the entire world, two of the most thoughtful, forward-thinking, interesting folks. So thrilled to add with them Kevin from John Deere. John Deere is being extremely thoughtful about the future of automation and their company's role in enabling farmers to do more with less. And so thrilled to have all three of them join us. I'm going to tell you first a little bit about Farm Foundation and who we are and what we do and why we're here today. And then we'll get into, I've got some questions I've been working on for a couple of weeks now, but I encourage you all to ask questions as well. So Farm Foundation is a 92-year-old nonprofit organization based out of Chicago, Illinois. We were founded by the CEO of International Harvester back in 1933. He got together with the governor of Illinois to create an organization that could move freely between the government, higher education, and the private industry, all for the benefit of farmers and rural communities. And we have done that for 92 years. We are unbiased. That means we don't lobby, we don't advocate, we don't take sides on issues, but rather we provide unbiased information so decision makers can make better decisions. But we're also an accelerator of practical solutions for agriculture. So we build very large coalitions to tackle some of the most important issues in food and agriculture. We work in 4 areas. I think, Kelly, if you want to jump to the next slide. Our mission is, here we go, perfect. Our mission is to build trust and understanding at the intersection of agriculture and society. And these are the areas that we do that in. At the top there is Farm Family Health. We provide unlimited mental, physical, and financial health services to all farmers in the United States. We built a coalition of every major farming organization in the US last year in order to provide these services. Market access and development. This is sort of our ag econ side of our organization. We're primarily focused on trade and supply chains. Down at the bottom, you see conservation and sustainability. We are one of the creators of the Soil Health Institute in North Carolina. We have done a tremendous amount of work in conservation over our lifetime. Currently, we're focused on conservation and sustainability practices at our new farm. We have an innovation and education farm about 25 miles north of O'Hare Airport here in Chicago, where we do a variety of conservation practices. And then to the right, you see digital agriculture. So data interoperability, which just might come up today, but it's a key issue in understanding what may or may not allow technology and traceability to advance in the supply chain. In the middle there, you see that we are a multi-stakeholder, intergenerational organization that works both locally, regionally, and globally on our projects. We have 9 different next generation programs focused on building the leadership for tomorrow across food and agriculture. So we're involved everywhere, but chances are you may have never heard of us. We are not a public-facing organization, so you will not see us advertising on television or anything like that. We very much work within the industry for change. Slide, Kelly. So the reason we got involved in this is we were lucky enough to take a group of folks in California a couple of months ago to visit FarmNG at their factory, as maybe that's not the right word, but at their facility in Northern California where they're building their robotics. And we were really excited what we saw there because there are so many issues facing farmers of all sizes and all types. Automation is probably one of the most important issues facing ag right now for the following reasons. Of course, labor being probably the most pertinent, but also the drive for farmers to cut costs in order to improve profitability, increased efficiency and productivity. This is a demand throughout the value chain. Improve consistency and quality, again, very much related to traceability and a healthy food system. Sustainability and environmental benefits, enhanced data collection and decision making. John Deere, often thinks of themselves as a data company, as a lot of folks do, rather than just a machinery company. They're thinking about the data and how they use that. So, super important there. Adapting to climate change, automation, I think, allows for a lot of new opportunities. Health and safety of our workers, and then finally, simply meeting the global demand for food requires the farming system to develop new and more efficient ways to produce, package, and distribute food. Next slide, Kelly. So to help us talk about these things, and I've got, like I said, a whole bunch of questions, but I think I'll let each of our speakers introduce themselves and tell you about what they do and how they're thinking about automation. I'm going to start with David Hill. David is a farmer from Central Florida. You'll find him just outside of Orlando. His business is a fascinating one. He went from being a pretty standard row crop vegetable producer in Central Florida, but because of climate and environmental change, they had massive change on their farm, which caused David and his wife, Lisa, to really think about new ways for them to stay in farming, but to innovate and do something a little bit different. And so I will leave David to tell the rest of the story.
Hey, Tim, hear me okay?
Perfect.
Okay. My name is David Hill. Thank you, Tim. And as Tim was talking about, we've kind of gone full circle in what we do. I've always considered myself a very old school farmer, conventional. And so for the first 30 years of my adult farming existence, that's what we did. And about 15 years ago, we started to we're right next to Orlando, and so we were seeing that things were getting kind of tough on the farm. So we had already started a couple years before, started to planted blueberries, trying to come up with a different crop, and then my kids kind of talked me into starting a blueberry U-pick, which is a small little tiny thing that we started just to diversify. Our first U-pick crop was in 2014. And so we've been doing it for like 11 years now, 11 seasons, and we've grown to a pretty decent size agritourism. Now we do, blueberries, strawberries, blackberries, peaches, vegetables, and sunflowers are a big deal. And people come and it's mainly pick your own. We've got a commercial side of our farm, which is blueberries and strawberries, but it's mainly a pick your own. So thinking about the topic, we don't do a whole lot of stuff with AI. I know that people have been working on a robotic strawberry harvester, which everybody is. I mean, we've been fascinated for a long time, but every time we talk to everybody, it's 5 years away, and they've been saying that for 10 years. So we're kind of waiting for something to jump ahead, and we've actually got people trying to do some tests, experiments on our farm, trials on our farm with some technology from UCF, University of Central Florida, right down the street, trying to do the same thing, which we've been kind of on board with. So that's where when I think to AI, I think somewhere to help us with the labor, because labor is so tight, and it's either too expensive or you can't find it. So I'm trying to think how, different ways that we could do that on our farm. I'm not sure. That's not my bailiwick, but I'm looking forward to talking to you guys about what you're thinking about.
Thank you so much, David. I think the fact that you guys haven't brought this technology to your farm is really one of the reasons we wanted you to participate in this, because what we really want is for the students that we're talking with today to partner with farmers like you to imagine, if you had access to robotic technology, what could it do on your farm? What impact could it have? So it's great that you're starting from the point that you are. So thank you so much for sharing that. And we'll dig into some questions here in a minute. But next, I'm going to introduce, believe it's Klaus Martins. Yes, so Klaus is a farmer in upstate New York. He and his wife, Mary Howell, and their family manage a diverse farm of row crops, grains, all sorts of things, including a dairy, which I think they're spinning off, if I remember that correctly. They've been farming for a long time, and I think what keeps their farm successful is their willingness to embrace change, to embrace opportunity, and to embrace technology. And every time I talk to Klaus, I feel like I have learned a dictionary's worth of information. A remarkable mind, and so thoughtful. So Klaus, thank you so much for joining us, and I'll let you tell your story now.
I feel like a little bit of an imposter talking about technology. Our farm has another generation coming along, and I've been trying to convince my son Peter to be in on this webinar because he is actually the one that's bringing technology. Most of the years when he was growing up, he'd ask me, how much do I get paid? And I used to tell him 60 minutes an hour. And then he said, but I'm going to get that all back with interest by having you work for me. So at this point, I'm working for Peter at about the same rate of pay. And he has one disadvantage. I go to Farm Foundation meetings, I go to webinars, I do other things. But we've been looking at the labor situation with trepidation, because when we bring automation in, we create the demand for a different type of skill. It's not that we're getting rid of help, we're actually needing a much more highly skilled type of help to make this automation work. And I'd like to invite Peter to come forward and talk. He interned in Germany on a highly advanced farm there. And then he found a really nice young lady who's now my daughter-in-law. And they've got a couple of little kids, but when they go back, they're keeping track of technology. And I think we need to keep track of what the Europeans are doing, because they're ahead of us in some ways and they're behind us in other ways. And one piece of technology that Peter saw there was a robotic system out of Denmark that we have imported. It uses a different concept than most of the robotic systems we're seeing here for weeding. And that is, it's got GPS at extreme accuracy. If I remember right, it's about 6 millimeters. And by knowing the location of every seed in the field, it can hoe around the plants with extreme precision.
And without having some of the technological overhead of having image processing, image recognition. It knows where all these seeds are. So the entire thing is operated by a Siemens PLC. The entire control package is built in a moderately familiar industrial control language for myself. The issue that I've run into is I'm the only one on the farm that can get along with it. I have good help. We had an intern who did his bachelor's at Cornell University. His girlfriend was in computer science. I had him monitoring this for the past 2 years, and we kept bumping into issues that he would eventually work through, but it wasn't intuitive. So I think that we have 2-3 generations of farmers that are good with their hands, probably pretty good mechanics, but maybe not electricians and programmers. And that's what we need. But we don't just need electricians and programmers. We need electricians and programmers that have an understanding of what's required to function on a farm. This autonomous robot that we have brought in from Denmark I would say they got the programming spot on, but if they had doubled the thickness of every bit of steel in it, it might have been adequate. They very much were focused on, let's keep this thing as light as possible. It's technically nearly perfect, but the execution just wasn't quite up to the type of soil conditions that it's going to run into in the general market. It has problems with stones. It has problems with soils that can be hard and crusty. And when I've brought that up with the company, they said, well, where we developed this is in a portion of Denmark that has black sand. We don't know what rocks are. Well, there's your problem. So we've been working with a company called Haggerty Robotics in Ontario. They are working with the Farm Droid. They're also working with the Agro Intelli Roboti and a number of other ones. And what they're seeing is that we're starting to figure out how to get these things to run, to follow the rows. But the next piece, especially if it's going to do any kind of tillage, is to have some form of image recognition to realize when there's a rock jammed or something, look behind it like a farmer can do and realize that the machine's not doing what it's supposed to. And it sounds like that is something that they're working on, but that's a whole another level of software development that is they feel is not being talked about as much as it should be.
Someone should have told them to hire at least 1 or 2 farm boys to be on the development team.
The Farm Droid was developed by 2 farm boys that went to university to study electrical engineering. They just had the handicap of growing up in an area that had very cooperative soil. So the next step is kind of confirmation of quality of work, and that's not something that I've read a whole lot about. It may very well be on some companies' radars, but I haven't seen any products in that direction. And that's probably more of an issue on organic farms where we are doing more tillage. I think if it was a conventional no-till mindset, you're going to be looking at spot spraying. There aren't as many opportunities for a physical issue to arise.
As far as the innovation in their in how they design the technology, I had a long time ago thought we should have the location of every plant, but it eats you alive in data. They made one very simple, ingenious innovation. They only need 1 point in the field. From that 1 point in the field, they run the same algorithm that planted the seeds, and then they can extrapolate the location of every single seed in the field from that. And that part, they got perfect. I keep looking at it saying, they got the hard stuff perfect. The easy stuff, they could use some help with.
Well, you guys gave a perfect introduction to our final speaker today, and that's Kevin Seidel from John Deere. John Deere has been a partner of Farm Foundation since our founding in 1933, which you might think is unusual, being that we were founded by the CEO of International Harvester, but it's because John Deere has changed a lot over the years. They originally were an implement company. They were not a tractor company, and at the time they joined with us, they were still pretty much in the implement business. As I said earlier, they increasingly are in the data business, but we're really lucky to have Kevin here, who's Senior Group Product Manager at John Deere, who's working on these issues of automation and thinking about how farmers, particularly specialty farmers, I believe, Kevin, is how they're using this technology and how Deere can help provide that. So, Kevin, I'll let you take it away.
Sure, thanks, Tim. I'm Kevin Seidel, and as Tim said, yeah, Senior Group Product Manager here at John Deere. I'm out of Des Moines, Iowa, and I'm responsible for building what we call the John Deere Operations Center, and that's our digital farming platform. That's the system that many of our customers choose to use to manage their operation, view and monitor all their equipment in real time, record data, capture data, and then use many of the tools that we have to analyze the results of their operation and use that to make a different decision next year, right, on what practices they'll do or how they'll do things differently to be more efficient, be more profitable, increase their yields, lots of different things there. I started out as a software engineer, computer science background, have moved into product management and lead a pretty diverse team of folks. Partnered with a couple peers who are responsible for much of our technology platform here at Deere, and I've gotten the opportunity to be involved in most of our automation and autonomy programs. All of our automation technologies run powered by our John Deere Operations Center platform. And so they take all the information that's been collected and use that to make improved decisions, be that with AI on the machine, predictive models, lots of different things like that. And we've got some experience putting some real automations and true autonomy into the market in certain areas. And so interested to be here today and hear what questions you may have for kind of somebody on the other side of the table, from David and Klaus and Peter, who's done some of this before, and maybe talking less about the farmer side of things, maybe more on the how to apply technology to solve problems, and how to break down those problems in the right way, and create a product that's truly useful to these guys. I would say there's a lot of technology that exists in ag tech, but just because technology does not mean it's practical technology, and it has to really work for our customers in their operation. You heard from Peter, things just like, oh, this doesn't work in our soil, and so it's not going to work, even if it's the most amazing technology, the best algorithm, the fastest NVIDIA GPU. Steel wasn't thick enough, right? And so it's not practical for them. So that's something that I hope to maybe provide you guys today of how to think about some of these problems and approach them, not just from a pure tech angle, but really to think about the true customer problem and the right ways to solve those.
Thanks so much, Kevin. I'll ask you the first question, and then I'll ask the other two to join in on that. And that would just be, it's sort of, if you had a magic wand, or if you had a Farm NG robot available to you today on your farm, what's the primary task you would want that to do? If it could do anything you wanted, what could it do? And Kevin, what do you think farmers would need more than anything?
It's a great question. I think it's hard to say. It's hard for me to say. It's a very wide answer. We serve a very diverse customer base of lots of different folks. So I'm going to defer that one to our true customers here, and let them weigh in on what they would like to see us do for them.
David or Klaus, either one of you can go next.
For me, I kind of brought it up, but harvesting, excuse me, strawberries. If we could have, and like I said, they're working on it, and if you could put something in the field that went virtually 24 hours a day, that could we could confidently pick the right, the right maturity, the right, without damaging the strawberry. That to me, that's a huge ask. They've been working on it a long time. We've got our family's actually got my son has a blueberry machine harvesting company, and with the machines that harvest blueberries, but that's not AI. It's just a repetitive motion that takes the berries off, and blueberries lend itself to that, but strawberries don't. And there's other crops same way, but that would be mine. There's see and spray stuff and that kind of thing, that kind of technology that works. We do a lot of our weed killing mechanically. We do a lot of cultivating and stuff. But mine would be definitely the harvesting of strawberries, and whoever's the one that cracks that nut is going to be a rich man or woman.
I'll let Peter.
I've got to run outside. We had a truck show up unexpectedly, but I can jump in right before I have to go. It's about 10 degrees here today, so everything's taking longer than it should. Fendt had something that they showed over 10 years ago, and then it just kind of died. I'm seeing a version of it that I think is coming from Raven now. That's a follow me function. We have a limited number of skilled operators. I don't feel like the automation of equipment is quite to the point where you can safely be without an operator in the field. But if we can have one operator, one skilled operator overseeing the machine that they are sitting in, that's probably driving autonomously on RTK, that can keep an eye on another one that's behind and to the side that's doing the same thing, and have the headland steering patterns figured out so that they don't get in each other's way, that would be valuable until we get to the point where we can trust the machines to have true autonomy. I guess another one I mentioned earlier is a little bit more proof of work monitoring so that the machines realize when they have a problem. And I'm going to run out. If the meeting's still going, when I'm done taking care of this truck, I will be back.
Thanks, Peter. That was
Tim,
I'd like
can I
to pick up where he left off. There's a big soil health component. What I'm seeing is our machinery has got, as you make it arithmetically bigger, it becomes exponentially heavier and requires exponentially more power. And I think we have an opportunity with robotics to have multiple smaller, lighter units so that we're not putting as much weight on the soil. And again, this goes with Peter's comment about having multiple units that are able to run in groups in the field. I think we would gain beyond the soil health. It would actually take less energy because, when we used to pull a 2-row planter with a team of horses, that was not a lot of power. When you go to 4-row, it took about 30, 40 horsepower. When we're up to 12-row, we seldom have less than 100 horsepower, but at 24-row, we're quite often 300. So our power and our weight is just going up tremendously as we go bigger. I think we have an opportunity to go smaller, and a lot of what we're seeing in the soil health arena, I think, is being aggravated by the extreme weight of these machines, especially during adverse weather events. So I'm just seeing this as an opportunity where automation and robotics could provide dividends that might be non-intuitive.
Kevin, did you have something you want to?
Sure, yeah. Peter made a couple points there that I wanted to kind of hone in on. That one of them was the comment around labor, and I think he said it very well. I just wanted to kind of reinforce it, that these guys are not looking to put anyone out of work, right? Rather, they're struggling to find anyone who is qualified to work. And so that's a key component that we're really looking at when we're looking at all this ag technology is we have a shortage. I mean, pretty much every customer we talk to says, I can't hire enough quality guys and gals to get the job done. And so just as you guys are thinking about this, I just want you guys to think about the problems in the right way, that it's a struggle right now. And so finding a skilled operator is really hard. And so thinking about how can maybe you make tasks simpler for less skilled, labor. There's less and less farm kids who've grown up on the farm who are transitioning into the operation, maybe like the Martins here. And how can you guys solve some of those labor challenges? And there was another word that was used, trust. This is very interesting and something that comes through a lot when we talk about technology. We may only get one shot a year, depending on the crop, to have a go at it. And these guys need to place a lot of trust into this technology. If it doesn't work, that can be a big problem. And so this is kind of, again, back to sort of the product and like user experience side of things. You can create the most amazing algorithm and the most amazing AI and all these things. How are you building trust into that system, though, so that the customers are going to think about some autonomous piece of equipment. How are they going to trust they're going to leave it and it's going to go and it's going to do everything? Just perfect. Trust me. It's really good. The algorithm's great. Well, when you only have one shot at it a year, it's really hard to put your faith into an untrusted, untested product. So it's just something to keep in mind as you guys are developing your solutions and ideas.
Thank you very much for that, Kevin. So thinking
You
about,
said, you said something really important there about the trust. I'll just bring an experience that Peter has that really drives him crazy. He hates getting a call on his cell phone from his robot at 3 o'clock in the morning because it does run around the clock. But whenever that thing has anything goes outside of certain parameters, it interrupts him, and it really is hard for him to do another job while it's going. You know, that's. I just thought I'd chime in with that because that's the reality of operating with an artificial intelligence running autonomous.
so David, the next question I'll direct towards you. So thinking about adopting robotics on your farm, what are the barriers for you? Is it cost? Is it technical expertise, scalability? Sort of what prevents you from having done this or not doing it at this point? What's prevented you from doing it?
I don't think the technology is there yet. Yeah, it's just that, yeah, it's like I was saying, they've been saying for at least 10 years, 5 more years, 5 more years. So it's a common theme. It's just that it's a really hard one and I don't know, I'm not an IT guy, of course. But to get everything right and the, for them to, the computers and the AI can think like a human now, but to be able to try the trust word again, to trust it to do the right thing, and be able to count on that. The thing is, it's going to, even when they get the thing figured out, it's going to take so long to get them in the field, and they're going to be expensive, and only the huge operations will be able to afford them until they get it down so well that they're somewhat mass produced and you can do it. But the cost is going to be huge. But the main thing is just the technology is not there, and so it. I assume it'll happen in my lifetime. I don't know, but it's the thing about it is you can't wait around. You got to keep going doing what you're doing to get the job done and leave it into to guys' hands, people's hands that are smarter than me, and they're motivated and they have the ability to stay at it long enough to do it because that's the problem. It takes a long time to get these things figured out.
Klaus, you made the decision to bring a robot onto your farm. Can you tell us your thought process in doing that? How long did it take to bring that to the farm, and how long until it was contributing to the farm?
It's still not contributing net income. What it is contributing is education and knowledge and experience. I'm not sure this is going to be, there's going to be a lot of ideas that are running at the same time. Just like at one time, there were hundreds of tractor companies, hundreds of car companies. We know who won out. We know who had the best technology now, looking back, but looking forward, nobody knew who had the best technology. And I think we're in that stage. There's going to be ideas and components of probably all of these machines that are worthwhile and that are going to come forward. And at some point, we're probably going to have 2 or 3 platforms that dominate. And we need to understand how to, how do we choose? How do we identify what works? This particular machine we got is really good. Peter had a friend who is a dealer in Germany, and he has 70 of these autonomous robots running in his territory that he sold the first year. Now that's a lot of sales on a machine that costs 6 figures, and each one of them is producing sugar beets. They've got a huge problem with sugar beets in Europe, with not having all the technology that's available in the United States, and also with resistance buildup. And by being able to plant these sugar beets and then come back through and hoe around each plant at a very high level of precision, it is actually a very cost-effective tool there already for that application. We wanted to take that tool and see what other crops would it work with. In Europe, they're paying 25 euros an hour for hand hoeing. So you could picture how much that machine is earning when it's running around the clock. Incidentally, that will hoe through in the dark because of the GPS. Daylight is not a factor for that. So I hope I've answered it. But we're trying to learn how to ask the right questions at this point, and I feel this is an investment. We don't think anything of spending $100,000 on an education. This is part of our education.
Thank you. So last week, we had our annual meeting at Farm Foundation, and I was asking as many farmers as I could about robotics. In particular, I was asking some livestock producers because I think we tend to focus a lot on row crops with robotics, but I see there's a lot of opportunity on the livestock production side. And so in quizzing some of these farmers, they came up with ideas like calving or lambing, just simply having a robot out there watching in the middle of the night to see what's happening and alerting the farmer when a cow may be struggling giving birth, or just simply showing signs if it's able to read her temperature to know what's going on. Same thing within milking systems, being able to read the biodynamic feedback from a cow to know where she's at, when she's ready to be milked, those sorts of things. Just other general health indicators. Also, what I thought was so interesting was predator prevention, particularly with lambs out in the field, using robotics to keep an eye about what's going on that may not be detected by a herder or a dog. One even said he's seen herding, that using robotics in terms of managing the movement of herds of animals, and then just basic tracking, keeping track of all of the data that's being generated on the field that's currently not at all being gathered or processed. So I would welcome any of you, Kevin, in particular, if you have other thoughts or experiences on the livestock side you'd like to share.
Sure, yeah, I'll start things off there. I think the area that I'm most knowledgeable about and closest to is maybe on the side of feed production. And that's another area that is target rich with potential opportunities. These cows don't stop eating, and they have to be fed every single day. And you typically, as a livestock producer, are going to also be somewhat responsible for growing the feed necessary to feed your cattle. And this is a very complex operation to get that ration right that those cows need to produce an optimal milk output. And so making sure that understanding kind of the relationship between the output and the quality of milk to the nutrition that went into the cow, and then upstream from there, even more hops in the chain to what were the practices in the field that were done, what were the fertilizers and pesticides and herbicides applied to the field, what was the protein content of the grain and the starch content and all different kinds of things in what you grew. And so trying to understand that, there's a lot of hops in the chain there where we lose the linkage. Maybe we understand the protein content on the field, but we don't know how that changes over time as these crops are ensiled and they're fermenting and changing their characteristics to become more digestible for those cows. And so that's another area that kind of on the input side of the production there, where there's potentially a lot of opportunities to help optimize.
I think it's interesting to look at milking robots. That is one example of a robotic technology that is much more mature than most of them. And I think it's because being able to hire labor on farms to milk is one of the real big problems. Peter did a tour when he was in Germany and Denmark and looked at robotic systems and talked to farmers that had them. and actually talked to a reseller. There's a business developing behind Lely that is maintaining their machines and refurbishing them. And people are buying actually secondhand units now that have been refurbished. And it is amazing that once they cross a certain threshold, that machine does a better job than a highly skilled human. You still have to have a person on the farm, though. And that's what he told me. He said, he doesn't especially like cows. And he said, you are not going to buy a milking robot because I'm going to be stuck keeping that thing running. You know, that you have to have the technical backup when you have one of those machines on the farm to keep it going. And, you know, and I think a lot of us, and I'm included, didn't have any idea how important that technical backup is, especially when you're implementing the new technology. But it continues to be like with these robotic milkers. They have to work perfectly. You can't just tell the cows, sorry, it's going to take till next week to fix the machine. You've got to have that. The parts have got to be there, you know, and the expertise has got to be there.
David,
Tim, oh,
go ahead.
I was just going to say you were on mute.
Oh, okay, thanks. So David, you've inspired one of our folks. Drew H asks, what are the current limitations of strawberry harvesters currently on the market or in process of being created? Are you familiar with anything? Oh, David, you're muted as well.
Sorry about that. I know Gary Wishnasky down at Wish Farms in Plant City, Florida, has been working on it for close to 15 years. And the limitations, I think, is twofold. Is one, recognizing quality berry that's mature, and then the act of picking, grabbing, and pulling the berry off the stem without damage, and you know, and placing it in the tray. It's just I'm not totally familiar with the whole package, but what I just is what I hear, and they have not. They're getting closer. I know they are, but there's and like I said, I was on the there's a group of students that have contacted us. And we were talking to them this morning, or talking. They got in touch with us. So they're after a block grant for that technology to keep going with that technology. So the limitations are vast. But the biggest limitation is the cost and the time it takes to develop. Unless you get block grants, or unless you're behind a huge company, a John Deere or somebody that's got the staying power to go through it for years and years, 10 and 15 years, that's what it takes to develop this technology. So that's, you know, besides the technology, it's the time and the money.
One reason we got excited about meeting Farm NG is that it almost feels like a democratic approach to bringing this technology to farmers, and that their platform is an open-ended platform. Their software is open. I think there is an opportunity, and what we liked about this competition was the ability for farmers to work directly with students who are developing these technologies. But the one thing I wonder about is data and data collection. And Kevin, maybe you'd be the best one to start this discussion off. But what are the expectations, but also the opportunities from also using these machines to collect and process data?
Yeah, it's a good question, Tim. Tim or Peter Klaus mentioned earlier around having data to understand what was done, and that is supremely important. Being able to understand how these systems are working, what are the results, right? The data, data's data, right? But what is the product you're producing from that data? And many times it's the scorecard for how well the technology is performing. And if the data can't tell David and Klaus a story about the product, they're not going to renew or purchase or buy more, right? That is how they're going to evaluate the ROI of this decision. And so it's kind of getting back to my point I made earlier. You can have the most amazing algorithm, but how are you selling that essentially to these customers? And um, having data, from them running it on their own operation for a trial period, being able to evaluate it and see those real results is really powerful. And you have to think about that in terms of the decisions and the outcome metrics that they're looking for, right? Is this something that's going to save money? It's an option. Is it going to save time? Is it going to reduce inputs? Couple of different ways to do that, to look at that ROI kind of calculation. But ultimately, it's really easy to capture just thousands of different measurements and whatnot. But how do you put those all together into something that tells a powerful story about your product and helps the customer make decisions? That's something that we spend a lot of time thinking about. And back to that trust point earlier, that's also a key component in building trust, right? Understanding, I let this thing go do a job. How did it do? That's part of building that trust, right? Maybe you're going to watch it happen for the first couple times, review the data. Once you see that the data is representative of what actually happened in the field, maybe you're going to trust it a little bit more. And so that's something to really keep in mind, right? Data for data's sake is pointless, but what is the outcome that you're going to use that data for?
And when we first started gathering a lot of data, the trick was actually finding the useful part of it, because there was so much. And I think artificial intelligence can actually help us figure out what is the pertinent, what is the important part of this. We have one other piece of robotics on our farm. We clean seed, and we brought in an optical sorting machine from China. And there's a real crossover to David, to your problem of figuring out, is a strawberry ripe and is it good? Because these machines use color, shape, and machine learning. They tell us that the most advanced optical sorters now will improve. The longer they run, the better job they do. Now, they have to be getting feedback that's useful, or that's not going to happen. And I'm not sure how they do the feedback or how the AI works, but I have seen the results. We're able to clean things as small as mustard seed and do a near perfect job going through one seed at a time. Each one is analyzed for color, and then they're sorted. We're cleaning dry edible beans, raised the bar tremendously. There was a time when it was acceptable to have up to 3 stones in a ton. These days, if you have 3 stones in a ton, you're looking at 3 lawsuits for someone who bit into a bean and broke a tooth. We wouldn't have a market if we were sending beans that had stones in them. It's interesting to see what's working. Which places this technology seems to be better adapted and has had more success than others. And I've just been absolutely amazed at how these optical sorting machines work. The other thing with the optical sorting machine is that most of them, you buy the machine and the company charges you about $500 for a set of settings, and it does one job. When we put ours in, Peter wanted to know from the technician how he set it. And we're finding that sometimes he's making adjustments 3 or 4 times in the course of a day because he's able to see something that it's not doing right. So there are very different levels of performance. I think somebody who buys that same machine and uses the canned programs is not going to give you the same rating on it that somebody who actually knows how to write the program or how to modify what it's doing to fine tune it, which again takes us back to needing highly skilled technicians on farms if we're going to be using this type of technology optimally.
And that was one of the questions we got in terms of technician. What sort of training tools do they need on the farm? So Plus, you probably have the experience with that of our group.
Well, that's an interesting cross experience because they really need to know what the farmer knows. You know, if you were going to be a technician who worked on a strawberry picker, I would think that technician needs to know how to pick strawberries, and not just the theory of it, but to have done so. That's my prejudice showing. But at the same time, he needs to have a completely different, or she needs to have a completely different data set or experience set and skill set on the other side, because getting into that machine and teaching that machine to do it, or adjusting that machine when it's not doing it quite right to get it right, is way above my head. I'm very fortunate to have a son who had an interest in computers from the time he was about 5 years old, and to be able to intuitively figure out how to make these things work, because I would have thrown up my hands and tossed it in the junk pile and said somebody else is going to figure this out, you know, instead of sticking with it.
So we've got a few minutes left. If you have questions, please enter them in the chat. I always like to give the opportunity for presenters to question each other. So if any of you have a question you'd like to ask one another, I welcome you to do that. So in thinking about, go ahead.
Yeah, are we like participants able to chime in as well about I just wanted to say hi to everyone, and it's really awesome that we have someone from John Deere here and some two ag experts because um I'm a student on the UCSC Electrified Slugs team, and so I've been kind of in and around this competition for a while now, and everybody said a lot of really interesting stuff during this talk, but seemed to as though this is a competition for universities. There is a real need for us as university students to start kind of questioning these experts. And, you know, we have someone from John Deere here, and John Deere is a very symbolic company in the United States because they have enabled a lot of the ag practices that feed all of the people in the United States now. And that being said, class said something about this weight of machines and the importance of small and light duty machines. And here with this challenge, university students have a real opportunity to think about alternative futures for agriculture that are not these very classic ones that are enabled by 7-ton, you know, wheat harvesters made by John Deere and can be a 300-pound ultra, you know, diverse kind of machine that can do compost spreading, weeding, and all of these different things. And as university students, it is our responsibility to be thinking about the future kind of, and listening to what these experts have said and what they have done, and taking that and running with it, and start to think about, you know, not everything that they have done in their lives, but what is it that we can do in ours? Because these people have laid the foundations for us almost, you know, they're experts, they are knowledgeable, we should talk to them, we should learn from them, but we should do it differently than they have. And that is super important, and that is super key with something like the Farm Robotics Challenge, because we are coming from universities. Universities are symbols of education in the world, where we have people from different backgrounds, from robotics, from agriculture, from biology, from chemistry, who are all here to make the future better. And we are playing into that when we are designing robots and designing software and designing machines and doing this kind of work. And so it's really important for us to not only question what they have done, but question and think and analyze and understand what are the problems with our food system right now? Why don't these people have the access to skilled workers? You know, what is the root cause of that? Is it like, what is it? You know, and I have my opinions, and I'm sure everybody on this call has their own opinions. But, you know, with this technology, we have a real opportunity to design the future right? And so as college students, we really have to do that and not just focus on the past and what people have done. And so like we need to talk to each other about what works and what doesn't. Because yeah, sorry, I can finish up, but
Appreciate that, Oliver. And you're absolutely right. Agriculture is changing fast, but what's changing faster is our environment. Climate change is having impacts on every single farm in America every year, and those impacts change every year. And so to kind of go back to what both Klaus and David and Kevin were saying is adaptability is key. None of these things can be static. They have to be able to be adjusted for literally to that farm's level, to that farm's need, to the need of that soil that that robot is working on. That's how precise this stuff has to become. And we're not talking 10 to 20 years from now. We're talking the immediate future. America at this point is the biggest exporter of soy and corn. Well, I can promise you in 5 years that's not going to be the case. We're going to be growing food in places where we haven't been growing it before. We're going to be growing different crops in places that have been traditional commodity crops, and we do not have the infrastructure and we do not have the technology for it. So your generation, I think, has both the opportunity and an unheard of challenge to making this work, and that's why we're involved in this challenge, and that's why I'm so grateful to David and Klaus and Kevin for being part of this competition. I would urge you all to reach out to us if you have other questions. If you need to talk to different kinds of farmers, we can enable those conversations at Farm Foundation. We've been around a long time, so we know lots of different farmers and different ideas. But I congratulate you all for your interest in this, and I wish you the best of luck. Thank you to our speakers. You guys were just wonderful, and I will give it back to Kevin.
I would like to throw out one opportunity I see. This is an engineering opportunity. Some of the most expensive components on big machinery are the gearboxes, the drive lines, the chains, the belts. These are parts that wear. They're parts that run in oil. Also the hydraulics. Electricity is a game changer. We can have a variable frequency drive and a controller replace a whole slew of things. You can have that motor with a variable frequency drive and a gearhead and a little bit of code essentially replace a huge amount of iron. And I think that could be a game changer in the cost of the equipment we're building, but it could also be a game changer in what that equipment is capable of doing. I just wanted to throw that out as, something I'm seeing just from watching these newer machines and the components that are in them, and also seeing what is giving the most trouble on the machines I've always worked with.
All right, Kelly, I'll turn it back to you.
All right, I think we'll take that as a good final comment. Really great program today. Thank you, Tim. Thank you, panelists. Thank you, students and faculty members for tuning in. We did record this, so we'll make sure to post that up on our website and share it. I think it was a great conversation, and I hope it really got those wheels turning to help you develop your products or projects and complete the competition. So thanks again, everyone, for tuning in. I think we're going to end it here, and enjoy the rest of your day and week. Take care.